Hello everyone, I'm Mohammed Islam Shishir and I'm back with another problem solving video. This time I'm going to be solving this problem called evaluate reverse polish notation. So what this basically reverse polish notation basically means that they're going to give you a number and then another number and then they're going to give you an arithmetic operator. So all we have to do is that take these numbers and perform this operation, and it's going to give us an answer. So this is basically it. Like that's basically what reverse polish notation means, and we have to evaluate the expression, return an integer that represents the value of the expression. Okay. The valid operators are plus, minus, multiplication and division. Each operand may be an integer or another expression. Okay. The division between two integers always truncates towards 0. This basically means that we have to like truncate the number so that the number is not a floating point number, and there will not be any division by 0. Okay. The input represents a valid arithmetic expression in a reverse polish notation. The answer and all the intermediate calculations can be represented in 32-bit integer. Okay. So they're going to give us an array of tokens, and tokens can basically be number and an arithmetic operator. So and all we have to do is this, like even in the explanation they're like letting us know what to do. So all we have to do is that, like, every time we get a number, okay, let's just visualize this inside our board. Okay, so like every time we get a number, like on the first iteration of our loop we get 10. So every time we get a number, we push it to the stack as a number. So we got 10 and we're going to push it to the stack as a number. So our stack is going to look something like this. Okay, then we go to the next iteration. This is again another number, which is 6. So we are going to push 6 inside the stack. So now the stack is going to be something like this. Okay, we go to the next iteration, which is 9. 9 is another number, so we are going to push it to the stack. Okay, go to the next iteration. So we have 3 now, so push it to the stack. So now at the top of our stack we have 3, and now we go to the next iteration. So this time we got an arithmetic operation. So now like every time we get an arithmetic operation, so to perform an arithmetic operation we need two numbers, right? So every time we get an arithmetic operation, we're going to pop out two numbers from the stack and perform that operation. So we're going to pop out 3, and the first number that gets popped out from the stack, it's going to be the left side number, and the second number that gets popped out from the stack is going to be the right side number. Okay. So all we have to do is like 3 plus 9, because the operator is plus. So 3 plus 9 is going to be 12. So 12, and now we are going to push it to the stack. So we are going to perform that operation and push the result inside the stack. Okay, so yeah, we don't need this anymore. Okay, now on the top of our stack we have 12, and now we are going to go to the next iteration, which is minus 11. So this is a number, so we are going to push it to the stack. So minus 11. Now we go to the next iteration. We get an operator, so we're going to basically like pop out two numbers. The first number is going to be the left side number, and the second number is going to be the right side number, and we have to perform multiplication here. So minus 11 into 12, that's minus 132. Okay, 132. So now we're going to push it to the stack, and we don't need this. Okay, now let's go to the next iteration. So we get another operator here. So we're going to pop out two numbers, left side number, right side number, and we're going we have to like, yeah, maybe this is what I'm getting wrong. The first number is the right side number. Okay, the first number is going to be the right side number, and the second number is going to be the left side number. Okay, sorry for this. Okay, so every time we get an operator, we have to like pop out two numbers. The first number that gets popped out is going to be the right side number, and the second number that gets popped out is going to be the left side number, obviously. So 6 divided by minus 132, 6 divided by minus 132, it's going to be minus 0 point something something something. So in the instruction, they said that we have to truncate towards 0, so we have to truncate this. Okay, so that gives us 0. So the answer is, the result is going to be 0 this time. So we are going to push it to the stack. We don't need this. Next we get multiplication. So the first number that gets popped out is the right side number, and the second number that gets popped out is the left side number. So 10 into 0 is 0. So 0 is going to be like, okay, so we have to push it to the stack. Okay, now we go to the next iteration. So we get 17. So we have 17 here. We go to the next iteration, so plus. So we pop out 17, the right side number, we pop out 0, the left side number. So 0 plus 17 is 17. So 17 is going to get pushed inside the stack. Then we get 5. So 17 and 5, and then we get plus. So we pop out the right side number, pop out the left side number. 17 plus 5 is 22, and that is the that is the result here. So that's basically it. Yeah, let's just code it out. Maybe that would make more sense. So we have to have a stack here. It's going to be an integer type. Let's call it stk. Now for const auto token of tokens, if the token is an operator, if the token is any of these operators, so in our case division, multiplication, subtraction, and addition, if it's any of the operators, we are going to okay, if it's not any of the operators, so we're going to push the token as a number. So stio, so the token is going to get pushed inside the stack as a number. And if the token is an operator, so we have to pop out two numbers. So the right side number is going to get popped out first. So stk.pop, and yeah, stk.pop. Okay, and then we get the left side number. Okay. And now we have to see what type of token we have got, like what type of operator we have here. So the first operator, if it's a plus operator, so we're going to stack push yeah, left plus right. Okay. And if it's a subtraction, we're going to subtract. If it's multiplication, we're going to multiply. And lastly, we don't need this, like obviously the only operator left is division, so we're going to divide. Okay, so that's basically it. Like every time we get an arithmetic operation, we pop out two numbers, and we perform that operation and push the result inside the stack. And if our token is not an operator, we push that number as a integer. So lastly, we are going like we would have one remaining number inside the stack. So all we have to do is that, like, return stack dot top. So this should work. Okay, let's submit this. Okay, so yeah, this was the solution for C++. Let's move to Python. Okay, so for this we need a stack. Okay, and for token in tokens, let's get a hash map here. So if we get a plus operator, so we are going to introduce a function or a lambda, bda lambda. It's going to receive two numbers, so a comma b, and it's going to return a plus b. Okay, if the operator is if the operator is minus, it's going to return a minus b. If multiplication, is going to return a multiplied by b. And for division, there is going to like we have to like truncate the numbers, so int is going to do the job here. Okay, now so if token in operations, so that basically means that it's an arithmetic operator. So if it's an arithmetic operator, we have to like pop out two numbers, so right and left. Stack dot pop and perform that operation. So stack dot append ops of token left comma right. And if it's not an arithmetic operation, then we're going to push it to the stack. So stack dot append token, convert it to integer, and then push it. Okay, so that's basically it. Now all we have to do is return the last element of the stack. Let's submit this, run this. Okay, submit this. So we are basically doing the same thing here. So every time we get an arithmetic operator, we pop out two numbers, and then we may do that operation and read append, like push that result inside the stack. And if we don't get an arithmetic operator, then we just push the number inside the stack as a integer. So yeah, now let's do this for Ruby. Okay, so we can use a different like approach here. So tokens.reduce, the main principle is same. So stack and token. So every time we get an arithmetic operator, so plus, minus, multiply, okay. So if any of this operator is like the token is any of the operators, so we are going to pop out two numbers, sticker.pop, sticker.pop, okay, and perform that operation, and then sticker.push. So in this case, if like when the token is plus, then we do left plus right. If the okay, that's just if the token is minus, left minus right, left multiply, left multiplied by right, and a division, we have to consider the floating point number here. So 2f to integer, okay, and at the last, okay. So and if it's not an arithmetic operator, then stack token dot to I, okay. So this reducer is going to return our stack, and all we have to do is return the last element of the stack. Let's run this. Okay, I should not have a semicolon here. Okay, now it should work. Okay, now let's submit this one. Okay, now let's move to the JavaScript solution. This is not going to be, yeah, okay. Now let's take a stack for, let's get trunk here to, from math, for token of tokens if plus minus dot includes token, that means the token is an operator. So right equals stack dot pop, left equals stack dot pop. Perform that operation and push it to the stack. Stack dot push, truncate the number. Eval is going to just evaluate this as a as an operation, even though it's going to be a string. So left token right, and if it's not an arithmetic operator, we are going to stack dot push number token. and finally return stack dot pop. Yeah. So this was it. This was the solution for the problem evaluate reverse polish notation. Hopefully you guys liked it. Yeah, let me know your thoughts in the comments. I will be back with another problem solving video sometime in the future. Let me know what kind of contents you guys like or would like to see from me. I don't know if I can like deliver that, but it's good to know. Anyways, thank you very much. See you later.